The Vera Rubin survey is underway. Could a spare Perseverance rover be going to the moon? 2 planets that are less dense than cotton candy. A vast, interconnected magma system on Mars. All this and more in this week's Space Bites. Well, Vera Rubin has gone through the initial tests, the commissioning, the engineering tests. We've seen some incredible images coming from this observatory, equipped with the largest digital camera in the world. And now, this week, their 10-year survey of the cosmos has officially begun.
So it begins.
Over the next 10 years, it's going to take 2 million images across 6 filters. It's going to download 30 petabytes of raw images. It'll detect 20 billion changes in the sky. It'll see 20 billion galaxies, 17 billion stars, and 6 million objects in the solar system. It'll be a 10-year movie of the entire southern sky. And if you've just crawled out from under a rock and you don't know how this works, Vera Rubin Observatory is this incredible, fast observatory that is able to take an image every 30 seconds of the sky and then move on and take another image and another image. And when it finishes that, about 3 days later, it'll start again and keep going. And I mean, for those of you in the know, the telescope has actually been live for several months. I've been reporting on this. We've been talking about how you can actually access the live data. You can go to data brokers, get additional information, and that this has all still just been the commissioning phase. And now the actual survey began this week. And we've seen in just the experiments, the test data, how powerful this observatory is. In just a month and a half of their optimization run, it found 11,000 new asteroids. It found 33 previously unknown near-Earth objects. And the hope is, if they can go past the 10 years, all the way to about 12 years, Vera Rubin should find 90% of the potentially hazardous near-Earth objects. That's a lot. The picture that I want to share with you is one of the images that was taken during its commissioning period. And this is where they were testing out what it might look like after 10 years as they're gathering all this data. Well, now we're going to get an image of this level of quality across the entire southern sky. We're going to get a movie of every single change that has happened in the sky over the next 10 years. It's going to be an incredible time. And it's like a decade I have been reporting on this observatory, and here we are. Let's go. And I can't wait to report what it finds. Got a story about this from Evan Goff. And if you want to learn more about what went into building this observatory, I've got an interview with the director of Vera Rubin, Dr. Edward Ajar. NASA's Perseverance rover is currently crawling around the surface of Mars, searching for evidence that the conditions for life were present on Mars for a long period of time. It's drilling in, grabbing core samples of rocks on Mars, holding on to them, dropping others down on the surface of Mars. Hopefully one day we'll bring those back and be able to study them. It is a near twin of the Curiosity rover, which went even earlier, back in 2012. And in fact, NASA has a third version of this rover. It's a full-scale engineering model that it has at the Jet Propulsion Lab. And so it can use this full-scale model to be able to test out ideas about moving through different terrain, seeing how it works with its instruments on simulated Mars conditions. Well, now we got an announcement that NASA is considering sending this twin to the moon. And you might have seen something like this when you watched The Martian, where he found the Mars Pathfinder on the surface of Mars. And in fact, there is a copy of it at NASA. And so they're able to test out what he was working with to be able to figure out whether they could communicate with him. It's sort of the same thing, but it is a real rover, and with some upgrades, some new instruments with an actual nuclear battery, one of these radioisotope thermoelectric generators. It could do this job on the moon. We got this announcement from NASA this week, and actually there's more news in a second, which I will talk about. But NASA Administrator Jared Isaacman said that they could take this engineering model and deploy it on the moon. Now, there would need to be some modifications. It has sort of different wheels. It probably has different instruments that it needs to carry on board, but it actually could be a lot of the way towards being able to send this thing to the moon. And NASA actually has a spare radioisotope thermoelectric generator. This is the decaying chunk of plutonium that is needed to be able to actually power this rover. And, we've talked a lot about how when you send rovers to the moon, the big challenge is they have to get through the lunar night. You've got 14 days of direct sun, great for solar panels, and then 14 days of bone-chilling cold. Well, a rover that's equipped with one of these RTGs can keep itself warm, keep itself powered through the lunar night. And when you think about the kinds of conditions that you have down at the South Pole of the moon, the really exciting place are the permanently shadowed craters at the South Pole. This is where there are deposits of water ice that need to be examined and mapped out. And this is the kind of rover that could do this. So we'll find out just how ready this rover is to fly. NASA has nicknamed it PROMISE, which is the Polar Rover for Observation Mapping and In Situ Exploration. So another backronym, but in this case, it makes sense. Curiosity, perseverance, promise, it fits. And if PROMISE does get upgraded and sent to the moon, then it will either go on a Blue Origin Blue Moon or a SpaceX Starship. And so this is just like another race, another competition for these two companies to find out who can actually deliver heavy payloads to the surface of the moon. And so, as I mentioned, NASA made more announcements this week about what its plans are for its upcoming moon base program. This is where they're just building out this infrastructure for the surface of the moon. And for the next couple of years, this is going to look like a lot of robotic missions going to the moon. And so NASA announced that they've selected 3 companies to land 4 missions on the moon in late 2028. So you've got Astrobotic, Firefly Aerospace, and Intuitive Machines. And NASA is contracting them to use their previously developed landers to send new payloads to the surface of the moon. And so there are 3 different kinds of instruments that NASA wants to see on the moon. A stereo camera for lunar plume surface studies. This will have an array of 4 cameras watching how rocket exhaust hits the moon and sprays up debris, as well as various micrometeorites that are hitting the surface of the moon. The second instrument is a laser retroreflector array. And these, of course, the mirrors that you can put on the surface of the moon. You then shoot a laser at them. The laser bounces off the retroreflectors back at you, and you can use this to time the distance to the moon and get really careful measurement about its distance. And then the last is called the Linear Energy Transfer Spectrometer, and this will help NASA understand the radiation environment on the moon. So 4 new landers, 3 companies. 2028 is going to be a pretty busy year. Once again, the universe shows us that it has many more tricks up its sleeve than what we have seen here in the solar system. Think about hot Jupiters. We don't have any of those. Think about super Earths. We don't have those. Mini Neptunes. Nope. And there is another class of planets that are so weird, and we don't have any of them here in the solar system. So these things are nicknamed super puff planets. I don't think I like that name, but unless someone can come up with a better one. And these are planets that are gas giants, but with a fraction of the mass of, say, Jupiter. So I'll give you an example. So astronomers recently discovered 2 new super puff planets called TOI 791b and TOI 791c. So they're in the same system, and they're located a little over 1,100 light years away from us. And so these planets are roughly the size of Jupiter, but they have a fraction of its density. And so the density of Jupiter is 1.33 grams per cubic centimeter. And as a baseline, water is 1 gram per cubic centimeter. A liter of water weighs 1 kilogram. That's the metric system. While these superpuff planets have a density of 0.04 grams per cubic centimeter, which is about 1/30th the density of Jupiter. And so these things are kind of like planet-shaped clouds. And so astronomers were able to detect these planets with the transit method. And in fact, when you ever see TOI, that is the TESS object of interest. And so the TOI planets were all discovered by the TESS mission, and astronomers could see them as they passed in front of the star. But they realized that the two planets have an orbital resonance with each other, and their gravity is pulling at each other. And so it actually changes. It causes delays in when the planets pass in front of the star, depending on how their gravitational influence is happening. And so I just love this idea that there are these super weird planets, like nothing we have here in the solar system, and yet they are out there and they're pretty common. Got a story about this from Mark Thompson. Uranus and Neptune are the ice giants of the solar system. And this term ice giants comes from what is thought to be the internal composition of these two planets. While Jupiter and Saturn are gas giants, they're made primarily of hydrogen and helium. It's believed that Uranus and Neptune have this thick atmosphere of hydrogen and helium, but then that's surrounding a interior that is made of what we would consider to be ices. So you've got methane, ammonia, and water ice. And then that layer surrounds a rocky core. And so that's why they're called ice giants. But observations from the Voyager 2 spacecraft and Earth observations have found that the magnetic fields around these two planets are not what you would predict with that kind of an interior. And so astronomers have been trying to figure out, well, could you change the interior structure of Uranus and Neptune to get something that better matches the kind of magnetic field that they see around those planets? And so a new paper came out, and they're proposing that instead of it having that icy interior that I mentioned, it actually has a magma interior. And so like the new structure would be, you have this hydrogen helium atmosphere, and then that surrounds a boundary layer made of hydrogen, helium, magnesium, silicon monoxide, and oxygen. And then below that is the magma ocean made of silicate iron and hydrogen. And so it's a totally different creature, totally different planet. And yet when you sort of simulate a planet made of those chemicals, you get a magnetic field that is more similar to what has been detected. But of course, this is all just from tiny little pieces of data that were gathered by the Voyager 2 spacecraft and observations from Earth-based telescopes. But we need much better data, which means we need to go back. We need to send a mission to stay at Uranus or Neptune. I don't care which, pick one, but we have to go back. Got a story about this from Lawrence Tugnetti. Every week we do a vote on our channel where you tell us what you thought was the most important space news story of the week. And the winner last week was the Link mission to try to rescue the Swift telescope. So thank you everybody who voted. We're going to put the vote for this week's topics onto the post tab here on our YouTube channel. So you can go in there, you can see all of the stories that we're covering, and then you can vote for this week and previous weeks, and then that will train the algorithm to show you more of this stuff in your feed. Of course, subscribe to the channel, click the notifications bell, like this video. With better observations of the universe, astronomers are learning more about dark matter. Of course, we still don't know what it is, but at least we kind of know where it is and how it clumps together and how it doesn't. And astronomers have found a variety of galaxies with different levels of dark matter. Galaxies with a lot of dark matter, galaxies with very little dark matter. And astronomers have even found galaxies that are only dark matter, just a blob of dark matter with just a couple of stars. And now astronomers have found another galaxy that seems to have no dark matter. It's actually a dwarf galaxy called DF9, and it's in this sort of long string of dwarf galaxies that appear to be part of some kind of galactic merger or collision. And so galaxies collided together and they threw out these chunks into space. And so when astronomers measured the galaxy, they were able to count up 100 million stars in the galaxy. They could see the visible stars. And then when they estimated the mass of the galaxy based on how it was lensing the light around it, it roughly matched the stars that they could see. And this is not what astronomers have been seeing. And so typically when astronomers do this process, they count up all the stars, the gas, the dust in a galaxy, and then they measure the mass of the galaxy based on how it is distorting light or how dwarf satellites are moving around it. It's more like 10 to 1, 10 times as much dark matter as there is regular matter. And in this case, it's all regular matter. And in fact, this is the third of these objects that astronomers have found as part of this string of debris that's coming out of this galaxy. And so, this still doesn't tell us what dark matter is, but it does indicate that whatever it is, it can be separated from regular matter. And so these giant galactic collisions can cause different distributions of dark matter from regular stars. And so that narrows the possibilities for what it could be. Like if it's that we don't understand gravity at the largest scales, you would expect that to always fall in line with whatever is the visible matter that we can see. But to have these sort of differences is really hard to explain with modifications to gravity, and gives more evidence to that it's some kind of invisible particle or primordial black holes, which I really like. Got a story about this from Matt Williams. Earth is the only planet in the solar system with plate tectonics, where we've got the planet broken up into these plates. You've got the less dense continents that float above the ocean plates. You get subduction, you get carbon cycles, you get a lot of the stuff that seems to help regulate the planet's temperature and make sure that the nutrients that life needs are available. And when you look at the other rocky worlds in the solar system, Mercury, Venus, Mars, they are stagnant lid, which is that they have this sort of complete shell of a planet and then magma inside. But obviously there is volcanism on these planets. Like, just look at Mars, it has the largest volcanoes in the solar system. Now, they probably haven't been active for a while, but once in the past, they were very active. Man, that must have been something to see these volcanoes erupting on Mars with the lower gravity and the lack of thick atmosphere. Anyway. And now, observations from NASA's InSight lander, which has not been operational for several years, but researchers are working on the data. They've found evidence that, in fact, the magma system on Mars is interconnected, possibly for hundreds or even thousands of kilometers long. And we have features like this on Earth, where you can have volcanic regions where they're actually connected by these long magma systems. But it was thought that on Mars and Venus and on Mercury, that you just have these hotspots where the magma is welling up through to the surface. And so it might be that these giant volcanic systems on Mars are actually interconnected with magma flowing through them. Maybe now, definitely in the past. We've got a story about this from Evan Goff. I hope you're enjoying this week's episode of Space Bites. Now, you might have had to watch an ad when you started watching this episode, and there's nothing we can do about that. But we don't put any ads in the middle of our episodes. We don't have any sponsored content in our videos. And that's just a better experience. But if you want to watch this video with no ads, you can for free. We put this video over on Patreon. And you don't have to pay for it. It's like just freely available over on Patreon. You can just watch it, no ads. So I'm going to put a link down in the show notes. Go click that link, go over to Patreon. And then while you're there, follow us for free on Patreon. You don't have to pay us anything. You can just get notifications every time we release a video. And so if you enjoy the videos, if you enjoy the news that we're releasing here on YouTube, you can get the same experience over on Patreon and not be dependent on some algorithm deciding whether or not you should watch our videos. We've got about 8-9 stories in this week's episode of Space Bites, but this is just a fraction of the stories that we're covering on Universe Today. Every week we do 30, 40, sometimes 50 stories on Universe Today about topics that I know you're going to love. A lot of stuff about SETI, technosignatures, gravitational waves, physics from journalists with, in some cases, decades of experience, advanced degrees. They really know their stuff. That's a lot of news to stay on top of. And so if you want a really convenient way to find out everything that is happening in the universe, I write my weekly email newsletter every Friday. It's completely free. I write every single word in it. Go to universetoday.com/newsletter to sign up. All right, I'm going to give you some vibes about how NASA is doing right now under the new NASA administrator, Jared Isaacman. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Andrea Pedretti, Brian Bodu, Caradon, Chuck Hawkins, Commander Bailock, Dark Finga, David Gilton, and David Matz, Enthrall Reading and Math for Toddlers, Evan.pro, James Clark, Jerry Mattern, Jim Burke, Marcel Smits, Michael Purcell, NASA Ocean Guy, Nordspace, OneStepForAnimals.org. Please follow my nephew at VBrick6994, Ren Kaidu, Richard Williams, Sean Sargent, Stephen Funley, Team 49, Telescopes Canada, Vlad Chiplin, Wolfgang Klotz, Zelda Oh My God, We Have Proof of Aliens, who support us at the Master of the Universe level, and all our patrons. All your support means the universe to us. So this week was actually pretty exciting, seeing the continued plans for the moon base and then hearing about how NASA might bring one of these engineering duplicates into service and send it to the moon. And one of the questions that we often get from people is like, why doesn't NASA just start to mass produce various rovers? Why don't they just? And the answer is that they just don't have enough money. They don't get the budget. They just get just enough budget to answer the science questions that they have and nothing more. And so you can't build two, you can just build one. But it's pretty exciting to see these economies of scale starting to be applied to the lunar exploration. I mean, I have lost count now of the number of landers and orbiters that are planned to be sent to the moon. You've got competition for contracts between Blue Origin and SpaceX. That'll give the best chance of having actual cargo delivered to the moon at a reasonable price for the US taxpayers. And right now, it really kind of feels like there is a new energy that is happening at NASA thanks to Jared Isaacman. And, I've been cautiously optimistic that he would be okay for NASA. He's flown to space. He has experience. He's kind of a implementer. And, the worry was that he would be sort of too much in the pocket of other established interests. And so far seems to be pushing back for a lot of that. You're seeing a good sort of respect for science coming from Isaacman. He's spacewalked. And so has sort of understands not just the experience, but the logistics of putting together some of these missions and a lot of the kinds of ideas about experimenting with nuclear rockets, nuclear reactors going to Mars, sending more helicopters back to the surface of Mars. And of course, all of this interest at the South Pole of the moon, trying to help get the Artemis missions on track. So that all feels good and right to me. There's a lot of stuff that was cut and wasn't necessarily his fault, such as cost overruns on the Mars sample return mission and things like that. And so I'd be interested to see sort of where NASA stands a couple of years from now under Isaacman's continued leadership. But I think so far, it seems to be going all right. But I'd love to hear your thoughts in the comments. Let me know how, what is your report card for how Isaacman is running NASA so far? All right. We'll see you next time.